Student, today we will discuss the resolution of a vector. Resolution means the breaking of a vector into two components. These components are called rectangular components because when we see the components that makes a rectangle. The component which is parallel to the x-axis, that is called horizontal component, and the component which is parallel to the y-axis is called vertical component. So to see more clearly, you can see this slide, uh, which is in which you can see more clearly a vector v when makes an angle theta. You know the vector v. You can say it's a vector f of force acts on a body, or it's a displacement covering, say, moving with respect to x-axis at angle theta. Uh, in the representation of the vector, you have seen clearly that you can represent a vector in any direction along x-axis. So if the force act on a body by making angle 30, 45, 60, so this vector will break into two components. If a vector act along x-axis, the force act along x-axis, that will not uh, break, or a force act perpendicular uh, on a body along y-axis, that will not break. So if a vector of a force act in between 0 to 90 degree anywhere, that we will break. So you can see here in this slide vector v. That's why we are taking vector v, because we can convert into either the velocity vector or either the force vector or displacement vector. But vector v is a suitable if vector v act on a body that making angle theta, so that will break into two components. Simple is a perpendicular is drawn from a point A, say on B on x-axis, so that will break into two component. The component of V which is parallel to the x-axis is represented by Vx, that is called horizontal component, and the component of V perpendicular parallel to the y-axis, that is represented by Vy, that is called vertical component. And this line you can see which is parallel to the Vx, and this line, you can see my cursor, this line which is parallel to the vector Vy, and it's nothing but a rectangle. It's nothing but a rectangle. You can see that this is the rectangle. That's why these components are called rectangular component. These components are called rectangular component. So very say clearly, I can explain here. Um Say that, for example, say this is a say the horizon. This is a, uh, a line where on a body is placed, say, along on a horizontal surface. So this uh, when an object is placed, say, on a surface, so if force act, say, for example, parallel to x-axis, so definitely this object will move, say, parallel to x-axis. The force act over here like that. If you pull it by a force F parallel to the ground or parallel to the x-axis, or you push it horizontally, so this body definitely will move uh, parallel to the ground will produce the linear motion. This body will move on the ground. But if you say if you say apply a force, uh, vertical force at 90 degree, so this body will not move forward, definitely will move upward or lift upward. So these are the two vector cases where one force is acting on the body parallel to the x-axis and uh, moving linearly along the ground. And in other example, when this body is say pulled upward, that will move upward, vertically upward, parallel to y-axis. Here, you can say that if I say that 10 Newton, for example, to uh, understand it more clearly, I'm taking, say, this is say 10 Newton force, for example. So this 10 Newton force, whole force will act to move it. And this 10 Newton, again, I'm taking, say, the 10 Newton force. So this 10 Newton force will fully act on its body to pull upward. Student, here one thing is notice, we are not breaking these vectors into component. Okay, but if the same force act on this body at any angle theta, so this 10 Newton force will not act on this body, it will reduce. Some of the force will say used to pull it on say along x-axis, and some force will act on along y-axis. I say this is the force F is acting and making angle theta. This angle theta is not 0 and neither 90, because the 0 angle 0 is this case say 1. This is say the case 1. This one is the case 1. More clearly, when the force is acting at 0 degree angle along x-axis, and this is the case 2 when the force is acting at 90 degree along y-axis and vertically, and this is say the case 3 when the force act at any angle theta. I say this angle theta, say 30 degree, maybe 45 degree or 60 degree, 0 to between 0 to 90, any value. But in these three cases, very much clear that when we need to break a vector, when we need to resolve a vector. So here you can say this 10 Newton will not act horizontally and vertically. I'm drawing the perpendicular from here. Okay, so look it. I'm drawing a perpendicular from here. Let's say I'm using a different color to show say clearly. I say uh, I say here a perpendicular from here I'm drawing. Okay, to show the breaking of a vector. This vector f, I'm going to break it into two components by drawing this perpendicular over here. And you say very clearly that this is say the y-axis. This one is the y-axis, okay? And this one is y-axis, which shows the vertical, and this is the x-axis. Now, very much clear that a force F is acting on this body by making angle theta. I say where this force is acting is a point O, and this is the vector A, and from A say a perpendicular is drawn on x-axis, say the point B. And if you say these are vectors, so you can see clearly in this diagram that OA is the resultant force, which was 10 Newton, and OB is the component of the force, which is say parallel to x-axis, and this is the component of F. This is the component of F, and say Fx, the component of F on x-axis. This is Fx, and this is the component of F, say along y-axis. So the suitable name is Fy. So you can see, student, you can see clearly in this diagram that only figure 3, in figure 3, this force we are breaking into two components, Fx and Fy, because that the 10 Newton here is acting by making angle theta. And in the figure 1, this force is acting on this body horizontally, and whole 10 Newton is used to push this body along x-axis or along the ground. And here this 10 Newton in the figure 2, and is 10 Newton is using to lift the body upward vertically. So there in these two figures we are not breaking the vectors into components, but here in figure 3, that this now F, which 10 Newton force is making angle theta. As I told you, that is maybe it is 30 or 40, 50, 60, whatever, but that will be in between 0 and 90 degree. In between x and y is 0 to 90. So very clearly that some of the force is used to push this body along x-axis, which is Fx, and some of its force is using vertically on this body, acting vertically on this body, which is Fy. Since these are the components of a rectangle, and you can see very clearly that it is making a rectangle, so you say that these are the rectangular components. Note it that these components are making a rectangle O, B, A, and if you say this point is C, so you can see a rectangle, and these components are rectangular component. So student, this Fx is called horizontal component, and this Fx is called horizontal component, and this Fy is called vertical component. And the values of this we can solve, we can get by solving this triangle OBA. You can see clearly over here, if I say triangle OBA, so you can see in the diagram this triangle clearly. And if you want to find the value of these components, so you have to use the trigonometric ratios. So student, this is a right angle triangle, and this so you can apply here the trigonometric ratio sine theta. Sine theta, you can say the sine theta is equal to sine theta is equal to what? uh, Perpendicular upon hypotenuse. So you can remember sine theta is equal to perpendicular upon hypotenuse, and yeah, you can remember sine theta is equal to perpendicular upon hypotenuse. So what is perpendicular over here? Fy. Fy is the perpendicular. And what is hypotenuse? The opposite to the 90 always. The hypotenuse in a right angle triangle. And where is the 90 degree? This is 90 degree. See here, because we draw the perpendicular from point A. So this is 90 degree. That's why the hypotenuse is F. And if you see that by cross multiplication, that if you want to find the value of say as fy, so this value of fy will be f sine uh, f sine theta. You can do the cross multiplication. Look at here, f sine theta. So your fy will be equal to f sine theta. Student, we are actually, this is the topic of the resolution or breaking of a vector. So I told you here that when we need to break a vector, number one, when that vector make an angle, uh, say any theta along x-axis, then we need to break the vector into component, and those components are fx and fy. Those components are fx and fy. Fy is a component, you can see in the diagram that fy is a component which is parallel to the y-axis, and this is called say the vertical component. This is called vertical component. And from the right angle triangle that is clearly shown in the diagram, you see clearly shown in the diagram that fy, you found here the value fy is equal to f sine theta. So anyway, in numerical example, when you will put angle value of the angle theta here in this diagram, so and the value of the force over here, so you can find the value of say fy. Again, now you're using the another trigonometric ratio, which is the cos theta, and cos theta is equal to base over hypotenuse. So see in the diagram what is the base of the or adjacent side, base or adjacent side. So OAB is the perpendicular, so OB is the base, which is fx. So student, you can see here, I'm going to put the value of the base, which is say fx, and again the hypotenuse has the same value, because you can remember that the side opposite to the 90-degree always hypotenuse, remember, and the side opposite to the angle always perpendicular or opposite side. So keep in mind when you were in a test or exam, that when you have to find the value of the horizontal and vertical component, so you can do this calculation here, which I'm doing here, that to find the value of the fx and fy. So this is the vertical and horizontal component. Numericals are very easy, and when you have to find the numerical value of the fx and fy, you have to put the value of the force f, as for example, I have given you that f is 10 newton, but angle value is not given. So if I say this angle is that if a force 10 newton is making 30-degree along x-axis and acting on a body, so you can say that angle will be 30 and that force will be 10, and when we will put here in there in these equations, so you can find the value. So inshallah ta'ala, when we will do the numerical, we'll see the use of these equations. So you can see once more, I'm going to explain in the figure 1, the force is acting along x-axis at 0-degree angle, so there is no need to resolve this vector. And similarly in the figure 2, and this force is acting perpendicular to the parallel to the y-axis or perpendicularly, so the body will move upward, and there is not uh, resolution or braking required. And in figure 3, that the force is acting on this body by making any angle theta, which you can say 30 or 60 whatever. So that will be resolved into component, and from in figure 3 you can see clearly from the point A. From the point A, we draw the perpendicular on x-axis, and we got this vector Fy, which is the component of the force F perpendicular parallel to the Y, is called vertical component, and I have written over V, the V for vertical component. Similarly, the OB is the say, component which is parallel to x-axis, is called the horizontal component, represented by H. And then if when the numerical value, I need to find the numerical value. So here I did the two calculations by considering the triangle OBA. This in figure 3, this is the triangle OBA, and which is a right angle triangle. So this angle is 90-degree, and I use two trigonometric ratios, sine theta and cos theta. And you can see calculation were very simple, that the when you put the value of the say perpendicular Fy over F, so by cross multiplication Fy is equal to F sine theta. Similarly, again you using the cos theta, that base upon height, and we say that the base is Fx, and that that hypotenuse is F, and the Fx and Fy. And a student, hand to hand, I want to explain that if Fx and Fy are given, so you can find the value of F also. So by the Pythagoras theorem, you can see over here that in this triangle, that the hypotenuse square and is equal to, this is the Pythagoras theorem I am writing, and you are familiar from the lower classes maths. This is the right angle triangle, that hypotenuse is the big side opposite to the perpendicular, opposite to the 90-degree angle, and this is the sum of these two sides. There is one is perpendicular and other is the base. So when you will put the value of that here over here, so you can find the H is F, which is the resultant vector or the resultant force, and the perpendicular is, you can see very clearly, which is Fy. Perpendicular is Fy, and I will explain it in a separate lecture also. But here, because the diagram is very clear, is very much clear, and you know what is Fx and Fy, and how can you find the value of the Fx and Fy. That's why hand to hand I am explaining that if Fx and Fy are given, you can find the value of F over here by simply by using the Pythagoras theorem. You can find the value of F. So student, I'll explain this in separately in a separate lecture when I will explain the resultant vector. So this I will explain again. So don't worry about it. But now you know very well that how can we find the say resultant vector, and how can we find the horizontal component Fx and Fy. And again we are going the previous slide. Now you can see clearly, you can understand clearly here, this is the vector V, as we are, as I have taken that V, or V may be the F, V may be the D, V may be any say the momentum, torque, or velocity, or acceleration, or force. So here, if a vector V is making angle theta, you can resolve that in Vx in Vy. Very much clear. I hope you understand. Here in this slide, again, you can take the say snapshot of this slide, or you can take the print of this slide. That's the resolution of vector is very clearly mentioned, although I have explained this thing already. but you can see a very clear diagram and clearly written over here. How can you find the sine theta? How can you find the sine, say sine fx and fy? This is the same thing which I have explained. And a student here in this diagram, again, the same thing is shown. And these are the component along x-axis and along y-axis. Vector A is making angle theta along x-axis. But one thing is different over here, that I and J, which was though these are basically the direction vector along x-axis and along y-axis. And you can find the value of ay a sine theta, and ay a sine theta means the a is magnitude, and ax is equal to a cos theta. As in the previous slide, you have seen that fx is equal to f cos theta and fy is equal to f sine theta. You can always remember as a formula. You can remember also when you have to say find horizontal and vertical component of a vector. So you can remember as a formula that Vx is equal to V cos theta and Vy is equal to V sin theta. As shown over here in this slide, A is a vector. So Ax is horizontal, which is A cos theta, where A is a magnitude, and Ay is equal to A sin theta. Okay, where A is the magnitude. So, student, you can see here in this slide, this is the addition of a vector, which is more lengthy topic and need more explanation. So, inshallah, I will explain in the next video. Hope you understand resolution or breaking of a vector.